Number 4, Tim is walking down the aisle of a speeding bus. Tosses a coin into the air, and obviously he catches it, hopefully. Matthew is standing on the sidewalk outside. So right now we're going to draw a trajectory, okay? First thing I want to say is, because almost everybody asks me, yo, what's trajectory? Think about trajectory is if you were tossing a ball, right? So if I had a ball and I was tossing this ball and the ball let out smoke, the smoke would tell me the line of which the path the ball would go. So if I toss a ball to the wall, the trajectory would be it bounce, and then it'd probably bounce to the ground as gravity pulled it down. So this line here, that's the trajectory. So if you threw something, there would be, and it was letting out smoke, that would be trajectory. And also, like, if you threw something and you knew the path it was going to take, so the trajectory in front of it, that's trajectory, right? Where it's going to go. Okay, so draw the trajectory of the coin from Tim's frame of reference. If it seems easy, just pause it and answer A, because it might be easy at this point. So Tim, remember, Tim is walking down the aisle of a bus. Yes, the bus is speeding, but he's going the same speed as the bus because he's on it, right? So if he tosses the coin, from Tim's frame of reference, it's just going to go up and almost go right back down. Bam, right? So this is pretty much all you do. You can design it a little bit different, but more or less it covers a very short distance and it just up and down, right? Now let's look at B. Matthew. Where was Matthew? You guys remember? Matthew is standing on the sidewalk. So if Tim's on this bus, let's go ahead and draw the bus. We don't need to draw this for your answer, but I'm going to draw it just to kind of illustrate it. So this is our bus. Tim is on the bus here, right? The bus is going fast. Matthew is here. Matthew is going 0 meters per second. And let's say Tim is going 40 meters per second. Okay? So from his perspective, when he tosses a coin up, it just goes up and down, right? Now from Matthew's frame of reference, Matthew is not moving whereas Tim is moving. When he tosses that coin, it's going to be in the air a lot longer, right? So it's going to look like it does this. You get it? Just like if you were standing still, right? And I tossed a coin, and I was standing still beside you. I tossed it, it goes up, it goes down. Both of our perspectives, it goes up, it goes down. Now, if we did that again, and I did this with a student, and they got to see this, where you're sitting in a desk, and I run past you, and I toss a coin up, down. That coin's going to be in the air. It's going to seem like it goes a lot further because it's moving forward with me. So when it goes up, and you can test this too. When it goes up, it's covering a lot more ground on the x-axis. Same ground on the y-axis, a lot more on the x-axis. Okay? So anyways, it's going to look something like this. It's going to go up, down. Notice it's a lot wider because, keep in mind, this coin is going 40 meters per second on the x-axis. So it's going to cover more distance, especially to someone who is sitting on the side looking at it. Right? So anyways, that is number 4. It's kind of a long answer for a long explanation for a short question, but nevertheless, it's important to understand. So there you go.